Alright, in problem number 3 we have a triangle, ABC. And we're given the lengths of side AC and BC, and we're told that there's 7. And the third side, AB, is 2. And so let's start with that. Let's draw what that looks like. We need a picture here. And I deliberately didn't put a picture with the problem just to let you have a chance to draw it yourself. So essentially we have an isosceles triangle. 2 legs are the same and there's 7. So they're fairly long compared to this third side. So let's draw an isosceles triangle. Alright. Well, that doesn't look quite I'm going to actually redraw that because I want one of the sides to be just a length of 2. So let's say that's a length of 2. And so the other side is going to be somewhere like up here. It's quite a bit longer than the other two sides. And that's probably still not to scale, but at least it gives you an idea. So this side is 7, this side is 7, and this side is 2. Okay? Not to scale. But and then we're told, and this is a little bit tricky here, is that there's a point D on line AB. Okay, wait a minute. We got to label these, don't we? So we have AC is 7, and we have BC is 7, okay, and AB is 2. Okay, that all checks out. And, okay, so we have this point D on line AB such that B lies between A and D. Okay, so we actually have an extension of this line here, the base of this triangle. And so we're going to call this point D. Alright, and B, it says, is between A and D. Okay, so here's B and here's A. Alright. And what else do we know? We know that the length of CD is 8. Okay, so we have a line. Let's connect this up here. And this is 8. And we're asked to find what is, let me show it in a different color. What is the length of this line BD, right? So I'll highlight that for you. Alright, so what do we got going on here? Well, essentially this is an isosceles triangle, and my hint to you would be to you can draw other lines on here, and because this is isosceles, if I drop an altitude here that ends up being perpendicular to the base of the triangle, then I know that this has to divide the base into 2 parts, or into 2 equal parts. Right? So this is going to be a length of 1, and this is going to be a length of 1, because it's isosceles. So you got all that symmetry going on. Okay, so because I like working with right triangles. If working with right triangles is a lot easier. I can use the Pythagorean theorem, and you can see now too. I have a right triangle here. Let's see, we could call this point E here, just for the fun of it. Alright, we know that the length AB is 2. Alright. And so this point E, there's a right angle there. And if you look at this triangle CEB, it's a right triangle, right? And we know a leg, and we know the hypotenuse. So we can use the Pythagorean theorem. Pythagorean theorem. Okay, which just says that the hypotenuse squared is equal to the sum of the 2 legs squared. Okay, so the hypotenuse squared is 7 squared, which is 49. And that's equal to 1 squared. And then we have this other side, we'll call that B. So B squared. Alright. So if I want to solve for B, I can just subtract 1 for both sides. So B squared is equal to 48. So that means that B is the square root of 48. Oops, 48. equal to that. Okay, and we know it has to be positive, obviously, because we're dealing with lengths of triangles. So this length right here is the square root of 48. Okay, and now I'm seeing another right triangle. Okay, I'm seeing, let me switch to colors here. I'm seeing a right triangle coming down here from C, alright, and going across to D and up to C, okay? And I actually know two of the sides. I know the hypotenuse and I know a leg, right? So we can use the same formula and we can actually solve for this ED side, okay? So, so that means that 64, which is 8 squared, that's the hypotenuse squared, is equal to the leg squared, 48, and then we're going to get this third side. We need a third side, so I don't know, let's call that, I'll just call it ED squared, okay? That's the length of ED squared. So I could have called this B, instead of calling this B, I could have called it EC or something like that. So this is EC. So if I want to know the length of ED, I can take 64 minus 48, and I'll get 16, right? And that's equal to ED squared. And so that means the length ED is equal to 4. Okay? So now I know that this length here, from E to D, is 4. I know that this is 1, so I know that this has to be 3, because I know it has to add up to 4. Alright? So, our answer is that the length BD is equal to, let's see, I can write it here, BD is equal to this ED, which is 4 minus, and it's minus EB, which is 1, which is 3. Okay, and we don't have any units on this, right? They're just giving us numbers with no units. But so this is the length of BD.